Earth isn't drifting alone in a peaceful void. It's moving through a cosmic shooting gallery, where danger and wonder coexist. Our planet is constantly traveling at incredible speeds, weaving its way through a vast expanse filled with hidden hazards. All around us we're surrounded by debris left over from the birth of our solar system, ancient fragments of rock and ice that never formed into planets. Asteroids, comets, and countless smaller objects zip around the sun in unpredictable orbits, and sometimes their paths cross ours, putting Earth directly in the line of fire. The scars of past impacts are everywhere, etched into the very surface of our world. The massive Chicxulub crater, for example, marks the spot where a colossal asteroid ended the reign of the dinosaurs 66 million years ago. And just look at the moon. Its pockmarked surface is a silent record of billions of years of cosmic bombardment, a reminder of how common these collisions are. Even in recent history, events like the Tunguska explosion in 1908 remind us that collisions still happen. A mysterious blast leveled thousands of trees in Siberia, likely caused by a small asteroid or comet exploding in the atmosphere. Most objects miss us by millions of miles, but a few come dangerously close, skimming past Earth and reminding us of our planet's vulnerability. That's why astronomers worldwide scan the skies every night, acting as our planetary sentinels, searching for anything that might threaten our world. Their mission is clear: spot threats before they become disasters, and give us time to prepare or even prevent catastrophe. Our journey through space is risky, but understanding our environment is the first step to survival. By learning more about these cosmic neighbors, we can better protect our planet. The universe isn't out to get us, but it doesn't play favorites either. It's up to us to stay alert and ready for whatever comes our way. Staying vigilant is our best defense, ensuring that we can continue our journey through the cosmos safely, no matter what the universe throws at us. Near-Earth objects, or NEOs, are asteroids and comets whose orbits bring them close to our planet. These cosmic wanderers travel through our solar system, sometimes passing within just a few million miles of Earth. While most NEOs are harmless, their proximity means we need to pay close attention to their paths. Most are small, no bigger than a car or a house, but some are massive, large enough to cause citywide or even global devastation if they were to strike. The largest NEOs are rare, but their potential impact makes them a serious concern for scientists and governments alike. The danger lies in their incredible speed and energy. An impact could unleash destruction in seconds, creating shockwaves, fires, and even climate changes. History shows us that even a single event can alter life on Earth. Thankfully, most NEOs will never hit Earth, but their orbits aren't fixed. Over time, gravitational forces and other factors can nudge them onto new paths, sometimes bringing them closer to us than ever before. Gravitational nudges from planets like Jupiter can shift a harmless rock onto a collision course centuries later. Even a tiny change in trajectory can make a huge difference over time, turning a distant object into a potential threat. That's why we don't just find NEOs, we track them, constantly refining our predictions and updating our data as new observations come in. This ongoing vigilance is key to our safety. Planetary defense isn't about sci-fi lasers or dramatic space battles, it's about careful observation, cataloging, and international cooperation to keep watch over the skies. By knowing where these objects are and how they move, we gain the most valuable asset: time. Time to analyze, to warn, and to prepare for any possible encounter. Time to plan, prepare, and if needed, act. With enough warning, we can take steps to protect our planet and minimize the risk to life and property. Our goal is a complete map of our cosmic neighborhood, charting every known NEO and understanding their journeys through space. The more we know, the safer we are. By staying vigilant and working together, we can ensure Earth remains protected from these ancient travelers. Watching for cosmic threats is a global effort. Telescopes and observatories worldwide, both professional and amateur, work together, sharing data around the clock. Robotic survey telescopes like Pan-STARRS and Catalina scan the sky every night, searching for moving objects. When a new asteroid is spotted, an alert goes out and the Minor Planet Center collects the data. Initial orbits are rough guesses, so more observations are needed from telescopes across the globe. Agencies like NASA and ESA coordinate follow-up, refining the asteroid's path. As Earth turns, observatories hand off tracking duties, ensuring nothing slips by. It's a seamless international relay, our planet's early warning system. Collaboration is key, no single country can do it alone, together we keep watch. In September 2024, The Catalina Sky Survey spotted a faint, moving speck, soon named 2024 YR4. The discovery was subtle, almost easy to miss, but it would soon capture the attention of scientists around the world. At first it was just another asteroid, blending in with thousands of others tracked each year. But as more data came in, its projected path began to worry scientists, hinting at something unusual. Calculations showed a small chance it could hit Earth in July 2025. Even a low probability was enough to trigger intense scrutiny, as the consequences could be severe. News spread quickly, sparking public concern and making headlines worldwide. Social media buzzed with speculation, and people everywhere began to ask, how dangerous was 2024 YR4? But scientists knew this was just the start. More data would clarify the risk. Teams across the globe coordinated to gather every possible observation, determined to learn more. 2024 YR4 was about 200 meters wide, large enough to cause regional devastation if it struck. Its size made it a serious object of interest for planetary defense experts. It was classified as a potentially hazardous asteroid, meaning it warranted close monitoring. This official status put it on the radar of space agencies worldwide. The world watched as astronomers raced to refine its orbit using every tool and telescope available. Updates were shared in real time and the global scientific community worked together. The key was patience and precision, not panic. Scientists knew that careful analysis would reveal the truth, and that jumping to conclusions could only cause confusion. Every new observation narrowed the uncertainty, bringing the world closer to understanding the real risk. Each night's data made the picture clearer. The countdown to answers had begun, and the world waited, watching the skies for what would come next. With global attention on 2024 YR4, astronomers deployed their best tools. Ground-based radar, like Goldstone, bounced signals off the asteroid, mapping its size, shape, and motion with precision. The James Webb Space Telescope used infrared to measure its size and analyze its composition. Was it solid rock or a loose pile of rubble? These details mattered for predicting its path and planning any deflection. Radar and space telescopes together shrank the uncertainty around its trajectory. Data revealed YR4 was a stable, rocky body about 210 meters across. Each new measurement tightened predictions, bringing clarity. The blurry threat became a sharply defined object. Science was closing in on the answer. The world waited for the final verdict. The YR4 story was a triumph of global collaboration. Observatories and agencies worldwide shared data instantly, coordinated by groups like the International Asteroid Warning Network. The Space Mission Planning Advisory Group began running deflection scenarios, just in case. Lessons from past missions like NASA's DART informed their plans. Scientists communicated openly with the public, countering rumors and explaining the process. Transparency built trust and kept panic at bay. This was planetary defense in action: science, teamwork, and clear communication. No secrets, no competition, just a shared goal to protect Earth. The system worked as designed. Humanity was ready, together. After weeks of intense observation, the answer arrived. 2024 YR4 would safely miss Earth, passing by at over 1 million kilometers. No danger, just a close encounter. Relief swept the globe, and scientists seized the chance to study the asteroid up close. This wasn't luck, it was the result of diligent, coordinated science. We proved we can find, track, and assess threats before they become disasters. For the first time, humanity isn't helpless against cosmic impacts. The YR4 story is a message of hope. Together, we can face even the universe's greatest challenges. Science and collaboration are our best tools. As we keep scanning the skies, we build a safer future. The cosmic shooting gallery is still out there, but now we're ready.